Zubrin.
Sure.
So great to see you here, and so good that we are starting our part 2. Remember the last part we had various discussion about why Mars is better than other celestial body for settlement, and we also discussed how lucrative is space mining and the challenging we are facing. And today I'm so excited to discuss with you something I found extremely relevant, that is the space economy and the market. So my first question for you will be that, Jeff Bezos has been always talking about that shifting the entire heavy industry to the moon and claim it will be done within the next 100 years. But in order for the heavy industry to shift, we need to start some basic infrastructure. So can we really expect the moon to become industrial base before Mars become a sophisticated human settlement place?
No, we can't. No, Bezos' thesis is absurd. We're not going to move heavy industry off the Earth. We're not going to put steel mills in Earth orbit and have to transport iron ore from the Earth into orbit to make it into steel, then bring the steel back down to the ground. Okay, this is just ridiculous. And so there's just no merit in it whatsoever. And no, we're not going to move industry off of the Earth. We're going to establish new civilizations on Mars, and we're going to establish new industries there for Mars. We're not going to export steel from Mars to the Earth. We're going to make steel on Mars to use on Mars, and possibly, initially anyway, for the asteroid belt. But the idea that you would China take its steel mills and put them on airliners up in the sky and move iron ore to the sky in order to make it into steel, then bring it back to the ground, that makes no sense whatsoever. Okay, the place where industries are is at least relatively near where the product is going to be, where it's going to be sold. Yes, we can ship industrial goods across oceans because ships are extremely efficient. The idea that we will make Earth steel on the moon is just wrong. It's just wrong.
But right now, consider every country's attention, it seems, all over the moon, right? Because everybody was talking about the lunar ice on the moon, so how that can use as a fuel. And, to do that, obviously need an industrial base. And then we have sufficient fuel, then we can get to Mars and asteroid. But in your view, actually, yeah, sorry, go ahead.
No, the lunar ice is of use for the moon, and we'll make rocket fuel on the moon using lunar ice, and we can use it to travel around the moon. But we're not going to transport lunar ice to the Earth to use in ice skating rinks here on the ground.
That's clear.
Yeah. We're not going to transport lunar rocks to the Earth to use to build highways on the ground. That is, if you're going to transport something across space, it has to be either something of great value or something that is unique, that you can't get anywhere else. So you're not going to take common commodities like rocks or ice or steel from the moon to bring to Earth. You might take helium-3 from the moon to bring to the Earth because there is no helium-3 on the Earth. And helium-3 is a potential fuel for fusion reactors that has a number of advantages. But and it would be extremely valuable per unit mass. But look, there are things that are valuable enough to transport across space, but they're not common commodities. They're not the typical products of heavy industry.
Basically, what you are saying is what we are going to get in space is have to be something really rare, right? And that part, I get it. But at the end of the day, even when we mine the asteroid, it seems uneconomic to bring the mineral back to Earth. So what you are saying is when we mine them, we bring them to the moon and then, to the Mars. And in the meantime, Mars has a lot of mineral resource which we can actually explore. So in that sense, that there is no need moon, so we can just jump to Mars. And does asteroid have value for Mars settlement?
Their asteroids have a number of things, okay?
Yeah.
They have platinum group metals. They have metals like cobalt and nickel, and they also have iron, okay?
Correct.
Now, iron is not valuable enough to transport to the Earth from the asteroids. Okay, that makes no sense. Platinum is.
Mm-hmm.
Okay, so it's simply a question of the value of the commodity per unit mass. Platinum is I don't know exactly, but thousands of times more valuable per kilogram as iron.
Mm-hmm.
So it makes sense to, or potentially makes sense to transport it all the way from the asteroids. On the other hand, iron, no.
Are we going to mine the iron at all, since there is no value for the Earth?
Well, the iron in the asteroids conceivably could be used to make things at the asteroid, because if you're going to make, say, heavy machinery there to help mine the asteroids, locally produced steel could be part of that, okay? But, and it's cheaper to, if you're going to do something in the asteroid belt, to get your steel locally than to bring it all the way from Earth, okay?
Can you actually set up kind of like heavy machinery on asteroid? It just seems like not very feasible. Consider the speed and the size of the asteroid.
Well, I think it all depends, okay? If you look at something like a machine tool, most of the mass of the machine tool is just steel. There's only a small percentage of it. Okay, first there's a small percentage is things like the motors, okay? And then even a smaller fraction are things like the computer control circuits, okay? So if you look at this levels of complexity, the most complicated stuff, the stuff that would be very difficult to create locally, is only maybe at most 1% the mass of this machine tool. And maybe 10% of it is the mass of things of moderate complexity, like electrical motors and such, okay? And the large majority of mass of it is things that is fundamentally simple, like steel structure. If you could make the simpler parts, just right there, just the simplest parts, the raw structure, you're saving a great deal of transported mass. Even something like you take this iPhone, which is a very complicated device. A lot of the mass of this is things like the glass on top, okay, and the structure and so forth.
So the point is, we can build the mass structure on asteroid, in your view.
Yeah, well, yeah, some of the things, habitations, other things that are needed, but actually things that are of medium complexity, including things like motors, and also things like food
that will come from Mars
and clothing. Yes, right. That can come from Mars, and it's much easier to get things to the asteroid belt from Mars than from Earth. In fact, if you had a starship fully fueled in Mars orbit, it could ship several hundred tons of cargo to the asteroid belt. If you had a starship fully fueled in Earth orbit, it couldn't even reach the asteroid belt with no cargo.
I didn't realize that. Can you actually just repeat that part again? I felt like you said if the starship was filled with...
If you take a starship, okay, Musk's starship, it has a dry mass of 100 tons and it can take about 1,000 tons of propellant. If it has no cargo at all, it cannot do the required delta V to go from low Earth orbit to the main asteroid belt. Whereas if it was in Mars orbit, it could take several hundred tons of cargo with it to the
Because
asteroid belt.
I guess because the atmosphere, right? Just make it so much easier once you are in the
Well,
space.
because the delta v, the required velocity change, is much less from Mars orbit than from Earth orbit.
Got you.
So this is a huge advantage. I did the calculation the other day, actually. Now, if you put the Starship not in low Earth orbit, but in a near escape orbit, that is like a place like the Lunar Gateway, which it requires a 3 kilometer a second delta V to go there from low Earth orbit, and you fully fueled it there, it could get to the asteroid belt with about 80 tons of cargo. But to fully fuel, to transport the Starship, the cargo, and 1,000 tons of propellant to the Gateway would require a total of over 40 Starship launches.
And the lunar gate is how far?
So it's
Lunar gate is how far
ridiculous.
From the Earth's surface?
The Gateway is about as far from the Earth as the Moon is, but it's not so much a question of distance; it's a question of the delta V, the velocity change, the amount.
So that's
of
almost like
energy
40
you need
times
to spend
if
to
it's
get
launched
there.
from the Earth compared to launch from the lunar gateway.
You'd have to launch the Starship itself and about 40 tankers, plus you'd have to refuel a whole bunch of tankers to go to the Gateway, and each of them would require lots of tankers, and it just gets ridiculous. So basically speaking, if we're going to mine the main
so basically
asteroid belt,
that's the transportation from asteroid to Mars is just so much easier. So it is going to create the ecosystem between these two. Okay. That's definitely
Correct.
very, very different from what the majority peer in space are thinking of the development pace. But it's a really, really interesting view. Before we going too much into about the Mars and space mining, and I would like us to come back with the next question of the space economy. So traditional industry invest into space industry and the sector like 3D printer and alternative fuel. You just mentioned about helium-3 and even agriculture. There's so much talk about the space agriculture, and with current climate change, obviously, I think it is really important for us to find alternative on Earth as well. So based on all that, which industry, according to you think will definitely starting benefit? And so much so, they were starting investing money into space industry and be benefit through these investment.
Okay, well, I'm not exactly sure what you mean by your question. Look, there's a number of industries that will greatly benefit space development. And you mentioned one of them, 3D printing. Another one is going to be compact nuclear reactors, for example, and so forth. So there are industries that are a bit cutting edge right now on Earth that need to be pushed further in order to enable us to efficiently settle space. Now then, a lot of these industries, once we start to settle space, the Mars cities, for example, will push them further. So let me give you an example from Earth history. Okay, the steam engine was invented in England. Americans took an early interest in it, and they advanced the technology greatly in order to enable it to be used to propel boats, steam boats. Okay, the British invented the steam engine. Americans invented the steamboat and did it very early. In fact, there was a steamboat called Perseverance, same as the Mars rover, okay, that was exhibited to the American Constitutional Congress, which drew up our Constitution in 1787. And the first successful steamboat, commercially successful steamboat, was built for use on the Hudson River. A guy who financed it was Robert Livingston, who had been a member of the Continental Congress and was also the guy who negotiated the Louisiana Purchase for America. Now, why did we push steamboats so hard? Because early America didn't have much of a road system. The only highway system we had were the rivers. And for rivers, sailboats are not terribly good form of transportation, and whereas a steamboat can go all over the place on rivers. They can go upstream. They don't have to wait for a favorable wind. It was enormously beneficial. And then while the first railroads were also in England, we pushed it much farther. By 1850, there was more railroad track in the United States than the whole rest of the world combined, and so forth. So you have a frontier society which needs these new technologies more than the old world does. Okay? And while some of these technologies will probably be started in the home country, in the home world, the colonists are going to be the ones who really say, oh, we really need, and they'll take 3D printing to the next level. They'll take nuclear power to the next level. They'll take fusion power to the next level, all these sorts of things. So these are going to be real engines of invention. That's what they are. Because the old world, by definition, has already figured out how to manage
itself. Do you actually
itself.
think that these companies, either it's 3D or agriculture, are they going to research and invent for the sake of space, or they actually just going to do that because they realize that something might have better application on the Earth as well? I'm just wondering if this industry is going to have
Well, no, in general, look. There's a few that will do things for space, but look, right now there's a lot more customers on Earth for anything you want to say. Okay, you name it. You got more customers on Earth than you do on the Moon or Mars right now. Okay, and that'll be the case for some time. Okay, but a lot of these technologies, I mean, certainly people right now who are invented 3D printing didn't do it for space. They did it for the terrestrial market.
I see. It's almost like a concurrently, right?
Well,
so it's like,
But certain of these technologies are going to be needed more in space. You take like nuclear reactors. Say, oh, well, nuclear reactors, okay, and I guess we can build some. But there's so many other ways to produce energy on Earth. You can burn coal, you can burn natural gas, you can even burn wood. You have waterfalls, you have windmills. Okay, you have all these things. Say, I might be willing to use nuclear power, but I don't really need it. I can do other things, okay? There are no fossil fuels on the Moon or Mars. There are no waterfalls. Solar energy has problems on both of them. On the Moon, you got 2 weeks of dark and 2 weeks of light. On Mars, the solar energy is only 40% as strong as the Earth. So it's not terribly attractive. But nuclear energy, well, you can do something with that. Nuclear power. But even nuclear power on Earth, why don't we have breeder reactors? You know, the nuclear reactors that are in general use on Earth only use about 1% of the energy in the uranium fuel that's mined. Only 1%. We could use over 90% if we had breeder reactors. And we've known how to make breeder reactors since the 50s.
economic.
Since the 1950s. But we don't. Because, guess what?
Exactly. I think last
the
time you mentioned
uranium
that as well.
fuel that you use in a nuclear reactor is only 5% of the energy cost. So somebody says, okay, so you're going to save me fuel. That's only 5% of my cost. Why should I bother with a new kind of reactor? The ones we have work fine and the fuel doesn't cost that much, so forget it. So that's the thing. Now, we can get cheap uranium fuel here because we have a worldwide network with worldwide transportation, so you can have mines in faraway countries and get the uranium to where you need it and so forth. You have a large worldwide division of labor to support it, and you could do this. But on Mars, you don't, at least for some time, we're not going to have a global transportation system remotely as good as what we currently have on Earth. Okay, so you might have to mine your uranium from places nearby with is inferior ore. Okay, and so you say, well, I'm going to want to get all the energy out of this ore, not 1% of it. So it becomes more important. Or other things. One reason why the uranium fuel is only 5% of the cost of a nuclear reactor is because the cost of the rest of it has been greatly inflated by regulators who have stretched out construction times. They've increased it more than tenfold. We just opened up a new nuclear power plant, first one in over 30 years in the United States.
Yeah, the rest is all
It took 14 years to build
rest
it.
is all
Our
compliance
first
cost, like
nuclear power plant took
compliance
3
time, I
years to
guess.
build. Yeah, but you think about that. With experience, we should be building them quicker, not slower. Now, the Martians are not going
Definitely
to
hope
be
so.
willing to have their nuclear costs inflated by a ridiculous bureaucracy. So we got to get this done. Then, if you cut the cost of
Yeah.
the construction cost by a factor of 10, now the uranium
Yeah.
would cost half as much
Got
as
you.
of the power, not 5%. And then once again, then people would say, well, we got to deal with that.
Absolutely. And I know you have your new book coming out, which is entirely devoted to the case of nuclear, right? And would love to hear.
That's right. There it is. The case for nukes. Okay. And
Yeah.
sure. And in that book, I discuss, well, first of all, I answer all the things that people bring up as why we shouldn't use nuclear power. They say that it can explode, and what can we do with the nuclear waste, and it can melt down, or it can do this, or it can do that. And their bottom line argument is it costs too much. Well, if the FAA, the Federal Aviation Administration, regulated airplanes the way the Nuclear Regulatory Commission regulates nuclear reactors, we'd have no airplanes. Okay,
100%.
It would be impossible. No, I mean, any business can be made too expensive if you have a hostile regulatory system. And that's what we have. So the book goes through all that. It explains why a nuclear plant cannot explode like a bomb, why all these other accident scenarios that the anti-nukes come up with are untrue, and it goes through how the costs have been radically inflated by a ridiculous regulatory structure. It also talks about some of the new kinds of nuclear reactors that we could have, because I don't agree with people who say we have to stop using nuclear power because the pressurized water reactor, which is the main type that people use, is an old design. It goes back to the 1950s. It works. We don't have to get rid of it. So it's not the last word in nuclear power, but it's pretty good. There's been over 1,000 of them built on land or sea over the past 60 years, and not a single person has ever been harmed by a radiological release from one of them. So it's a good design. Now, there are more advanced designs. As I said, there are breeder reactors, for example. There are reactors that can use a cheaper kind of fuel called thorium. There's reactors that are actually pressurized water reactors, but they're built to be modular, and they can be mass-produced in factories and then quickly assembled on site. So it's just a more economic way to produce a pressurized water reactor. Those are called the small modular reactors. I think they have a lot of possibilities. So there's all sorts of things that people are working on, and there's a whole entrepreneurial revolution going on with a whole bunch of nuclear power startup companies.
Absolutely. I feel that is really the key. That's really the bottleneck, and I totally can feel. I feel like we almost need to do an entire new podcast just about the nuclear and the nuclear industry and what is actually blocking us on the Earth and how it could, benefit us in the space, and maybe in return, then on the Earth we realize that a lot of things can be improved. So come back to our question. Basically, I think your point is a lot of technology that is designed for the new world, maybe not so much need for the old world, but because the application right now has more utilization on the Earth. However, so the technology were built for the new space, and along the way they realized that we can actually get more economic return on Earth. So that kind of like a coexist, right?
That's right. It's a reciprocal process. You got it exactly right. That is, Earth will create the first versions of the technology. Mars will then
Exactly.
greatly advance the technology for its own reasons.
I think that's what we see, right? I mean, maybe the 3D printer was starting some, on the Earth in the space, and then it probably is a must in the space because we just don't have enough facility and heavy industry plants to do that. But then now it bring back to Earth, then all the things 3D print just have so much more application. So yeah, 100% agree. That brings to my next question. So what are the most important space-based technology and applications that will drive the growth of space economy? And how do you see them being commercialized and being scaled? I guess some of them you already answered in the last question, but yeah.